Alright, what is up guys? So today we're going to be doing the ugly numbers level 2. This one is a lot harder than the first one, so if you haven't watched the first one, go back and watch it and then come back here. Okay, so I'm going to assume that you guys already know what ugly numbers are. Basically, they are just numbers that are divisible, or their prime factors are only 2, 3, and 5. So what ugly numbers 2 is asking is, so ugly number, I'll write the title up here. Ugly number 2, level 2. This is asking, find the xth or nth ugliest number. Find the nth ugly number. Okay, so brainstorm, naive way to do this would be, well, we already wrote a function that tells us is ugly. So why can't we just do a for loop that goes through all the numbers and just counts? If it's ugly, then like that count goes up, and we keep looking until our count is n, right? And so once it's n, then the nth number that we got, the nth number that's ugly, is the one that we're going to return. Well, we can do that. We can do that. However, it's not very clear, the time complexity. Why is it not very clear? Because ugly numbers could be spaced out very far from each other. So if I'm asking you to find the 2000 ugly number, you're going to be going a lot more than 2000 numbers. You're going to look through a lot more than 2000 numbers. It is really not clear how far apart these are. You could be going, this complexity could be enormous, all right? Dealing with ugly numbers or prime numbers, they're kind of similar to prime numbers, it's really unclear how far they are apart from each other. Okay, so there is a way to do this in O of n time. O of n being, if you're looking for the nth ugliest number, I could do it in n steps. And how I'm going to do that is I'm going to do a bottoms up approach. So I'm going to start with the base numbers, 2, 3, and 5, and then I'm going to find the fourth ugly number, fifth ugly number, dot, 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 until we get to the nth ugliest number. Okay, so in order to do this, the first thing I want to point out is, let's say we have a list of the ugly numbers and they're really long, and then if we have this many ugly numbers from here to here, tell me how I could find this, the next ugliest number, if I give you a vector that is this long and already has these ugly numbers. Well, what you can do, now pay attention here, is you can find the minimum between 2 multiplied by any of these numbers, so I'll call it x, 3 times any of those numbers, or 5 times any of those numbers. And obviously it needs to be greater than the previous one. So it needs to be greater than this one, than the previous one. Okay, and then what is the minimum between these three? So how close? So using a previous value, one that you know is already 2 times 3 times 5. Okay, so multiplying this one by 2 is still going to be ugly. Multiplying by 3 is still going to be ugly. Multiplying it by 5 is still going to be ugly. Okay, so that's how you know the number is still going to be ugly. Now we're looking for the one, maybe it's this one times 2 is like maybe 2 more, or no, maybe it's like 4 more than the last number. And then we have 3 here. 3 times this is actually going to be 5 more than the last number. Okay, so 2's winning so far, but maybe then 5 times this one is actually only one more than the previous number, right? Notice that it's not always going to be 2 times a number is going to be the minimum between these three. 5 could definitely be the minimum of those three, as long as it's greater than this last one, you know? Okay, so that is the idea. So how do we find this x, y, and z? Do we just traverse the whole thing and try all the well, no, we wouldn't have to do that. All we would have to do is go until it's just over 5 times any of these numbers is just over the last one. 3 times any of these numbers is just over. Because if we already got over, we wouldn't want to continue checking, right? Because if we're already over this number, then 3 times, like, for example, the next number is going to be even more over it. Okay, so that is one way we could do it. We could just traverse from the beginning and find it. However, there is a more systematic way to do this so that we don't have to go through it every time. If we did, then this would be O of n squared, and that wouldn't be the worst complexity. That wouldn't be that bad.
This is cutting it too close. I'm submitting them right now.
So...
He just called me. Should I call him back now?
Then
no!
It's taking too long.
Okay. Then I'll be...
So, okay. Then what we can do is... What we can do is we could start off with like having okay, sorry, there's just distractions here. So we could be multiplying 2 by this one. That might get us a number here. And if it is the next number, let's say 2 is the next number. I shouldn't have drawn these here. Let's say 2 times this number here is going to be the next number because it's the min or something. Okay, that means that if we use 2 times this number to go here, then we shouldn't have to multiply 2 times here again. We can move the 2 thing over. We could have kind of like a pointer of the next element that is, or okay, better way. If we just use 2 times this number to make this number, then we should be moving the 2 pointer over, because if we leave the 2 pointer like times here, then it's not going to be greater than this element when we get to the next one. So we need to move the 2 pointer over to here. Okay, one more time of explaining it. Let's say we're basically going to have a 2 pointer and a 3 pointer and a 5 pointer. So let's say the 2 pointer is here, and the pointer being like, instead of traversing, let's say we already know our candidates for the next number, and let's say we're trying to find this. What's the next number here? And it has to be greater than the previous number. Okay, so all of these are candidates, where 2 and wherever 3 is and wherever 5 is. Okay, but let's say it's 2 times this number is the best fit, is the closest to the previous number. So we use it. Okay, then what we should do is we should move the 2 over by 1. Because if we leave the 2 here, it just doesn't work, because the next number that we're looking for right here has to be greater than the previous number. And if 2 remains here, 2 times this number is right here. So it's not going to work. 2 has to move over by 1, so it's here. You could also think about it as this is the next best candidate for 2, right? 2 times the previous number equaled this number, So we need to do 2 times what number? 2 times what other number is going to be just greater than this number just greater. Which number times 2? Let me rephrase it like this. Which, after we do 2 times this number and put it in here, what number times 2 is going to be greater than the last number? Which one is the minimum? Oh God, why can't I word this? Okay. 2 times what number is going to be closest to but greater than the newest number? Well, that it would only make sense if we move 2 over here. If we move the pointer of 2 over here, then that wouldn't make sense because 2 times this number here is smaller and also greater than our last number. Okay? Okay. So how do we do this? So what we could do is we could first put in a 1 here and then have all pointers 1, 2, 3 for 2, 3, and 5 all pointing to 1. And then we compute the min, which is going to be 2 times the pointer, which I'll call x. Maybe I should have done it like this, x, y, and z here. 2 times x, 3 times y, and 5 times z. So which one is the smallest? Well, it's going to be 2. So we put the 2 here. And then the x, and then, okay, here's the thing. What should we do? Should x remain here? Well, we just put 2 times what x was pointing to here. Okay? So that means x is now equal to the last pointer. So in order for x to ever have a chance of getting to a new number, it needs to be slightly greater than this number. So we move x over by 1. Okay, if we left x here, then it just doesn't make sense. X, which is 1, times 2, needs to be greater than the last number. The last number is now 2, right? It equals that last number. So in order for x times 2 to have any more chance, we need to move x over by 1. Okay? That's why we moved it here. Okay, next question. What is the min now? What is the next ugly number? Is it 3, 5, or this is 4? Well, it's going to be 3. So we put a 3 here. And so now, this 3 was because we did y's number, which is 1, times 3. If we let y stay at 1, it can never help us get the next number. It's not greater than the next number. We need y times 3 to be greater than the next number, but just greater. We want it to be the smallest number that's greater than the last number. There we go. That's what I meant to be saying. That's what I was trying to say before. The smallest number that's greater than the last number. So y now equals the last number. So what we need to do is we need to move y's pointer over by 1. Is this guaranteed to be greater now? Is y's new pointer times 3 guaranteed to be greater than the n number now? Is it now? Well, yes, because when y was here, it equaled this number. It made this number. So incrementing to where y is pointing to y is becoming a larger number, and so obviously y times 3 is going to be bigger than what y was before times 3. Okay? And it's also going to be as small as it can while still being bigger than the last number, which is always what we're trying to do. We're trying to move the pointer to be just a little bit, so when the pointer is times its given number, it's just a little bit bigger than this next number. Okay, so now what's the next number here? Well, it's going to be 4 from 2 times 2. Okay, So we know 2 times what x is pointing to, which is also 2, is equal to the last number. So now we need to increment where x was, so that x is just a little bit, so that x is pointing to the number such that x times 2 is greater than the last number, but also the closest to the last number. So it has to be the greatest number, so it has to be greater than 4, but as close to 4 as possible. So that's why we incremented by 1. Okay, great. Now we have 5, because 5 times 1. And let's rephrase this again. So 5 times 1 gets you there. So in order for 5 to contribute, we need 5, or the z pointer, to move to the next one, because z already did its work with 1. Okay? Okay, and then let's get to this case where we got 6 and 6. Y, which is 2 times 3 is 6, and x, which is 3 times 2 is 6. So when that happens, both of those get to increment. We can't have 2 6's, so both of them increment. So we got y pointing here now, and x pointing here. And that makes sense. That makes sense because it makes sense why we increment both of them, because once we put a 6 down, y can't be pointing to 2 anymore because it's not greater than the last number, and x can't be pointing to 3 anymore because its times 2 is not greater than the last number. So then the thing that they point to is a number such that times their respective numbers, coefficients, is the smallest number that is greater than the last number. Okay, so I think we can now get to the coding block. Okay, let's look at the answers. So first what we do is we put a vector in with a 1 in it. Yeah, this is just a size 1 with filling in 1. Then we have x, or I, j, k is what we put as x, y, z. And then we are going to go to while size is less than n. Yeah. Okay. And then we have, why is this not less than or equal to? That's what I was pausing to think about for a second. So this is the size is less than n. And let's say we wanted the first number, so that's going to be, the size is going to be 1, and then n is going to be 1. Interesting. I'm just blanking on why that would be. If we wanted the first number, that means n would be 1. I want to see what happens when we put 1 in. I believe the answer would be 2. Oh no, it is 1. 1 is the first number. Okay. Well, in that case, then yeah, it works, because then the second number is 2. Okay. And then what we do is we find the min. So everything's pointing to 0, right? That's how we started off here. Everything was pointing to the 1, the 0th index, aka 1. And then all this is saying is if you picked the 2, so it's like saying if the back number is now the 2 times what it was, then you get to increment I. And why it's labeled like this is so that when the case happens when there's 2 numbers, like here, that both equaled 6, then you'd be able to increment both I and j. Because here it would be, for example, the index I was pointing at 2, so it was pointing at 3, and 3 times 2 is 6, and then 2 times 3 is 6. So then both of them get incremented. And this could happen, this happens a lot of times. So you always want to be doing that. Okay, so, and then you just output the back number. So to recap, why this works is we are listing out the numbers in order. We are listing out all the ugly numbers, x, y, and z. If we look back here, that was a strategy such that x times 2 is always going to be, is the smallest. Okay, well, let me think of how I explain this. X, the product, no. X is the smallest number such that 2 times x is greater than the previous number. 3 times y, y is the smallest number such that 3 times y is greater than the number, and z is a number such that 5 times z is the smallest number such that 5 times z is greater than the last number. We are trying to get the next number here is the smallest ugly number that is greater than this one, right? That's just the definition of the next number, the smallest number that's greater than here, right? And these are our candidates. How we get our candidates is using this method. They all start at 1, and when we use one of them to get the last thing in the vector, we increment where that was pointing to. Because there's no chance of it being pointing where it is right now. It has to move over 1 to the right. Okay, I'm going to recommend you guys think about this a bit more. This is a mathy concept, and it's definitely good to understand for many types of interview questions. So that's all I have for you today. Hopefully you've learned something and have relaxed in the process. And this is another nice CCT show I'm showing you how I go through these interview questions, and I'll see you next time.